Hey everybody, welcome to Houdini Hangout. We are in the first full week of January. I hope you're all doing well out there. Um, just it's getting a bit cold up here in the northern parts of the U.S. and just kind of getting ready for winter to really fully hit. But I think we're gonna have a pretty cool stream tonight. I'm excited about the topic. I'm going to be doing some rigging, talking about that. And for like the first time ever, I'm not doing I'm not doing programmer art. So I have some actual assets to use, which will be really cool, and we'll talk about that in a second. But hopefully everybody out there is doing well. Had some good feedback just on social media and stuff like that. People seem to be interested in talking about this, so I think that's really exciting. And hopefully this will be a cool conversation, and we'll be able to try to TTS through Discord. I don't know what that means, like text to speech. Is that a thing? I don't know if that's a thing. Oh, the Apex stream. Well, so I guess I should have been a little bit more clear about that. We're not going to be diving into Apex tonight. This is not an Apex thing. Mainly because, well, first of all, I don't know Apex, so I can't say that I'm would have any ability to talk about that. But I think this should be a fun look at rigging and things like that. And truly, rigging concepts are rigging concepts. Yeah, I'll definitely promote it as an Apex thing. Yeah, this is all going to be just KineFX stuff tonight. Apex is still a bit in beta, and there wasn't a huge. I'll focus on driving. Good. Yes. Don't crash your car. God. I'll see something on like Google News or something that some person was distracted driving, crashing into stuff on their way home from work or whatever. But yeah, so this is going to be KineFX stuff, so hopefully that doesn't diminish the excitement too much. But I think it's a cool setup nonetheless, and I think it'll be good to learn. As far as I know, a lot of the KineFX stuff will, it's kind of going to be there for there's going to be like building blocks that you're going to be using. Thanks, Stream Elements. It's going to be sort of like, I think there's kind of a interplay there. I don't think we've just thrown the whole old system out. I think there's just differences in how those things get executed and how they work with Apex itself. So I don't think that this is Max Rose. I'm not familiar with that name. I'll have to take a look at who that is. I'd be curious. Let's see. Let's do Houdini. Oh, cool. Interesting. Wow. That's really cool. Yeah, so he's got some Apex stuff in here. Cool. Yeah, that would be really neat to kind of talk about that and see how that might be different. Let's take a look at his stuff and see what's going on. Anyways, certainly could be a cool person to have on as a guest. There's certainly a lot of people that I could maybe talk to and have on the stream. So anyways, tonight we're going to be talking about rigging this little robot and doing some character stuff and kind of my learning process and walkthrough of this. So the first thing I should say is that we have this cool little model from, oh, there goes fade. It's from Igor Zanich. Nope, sorry. Igor Severik. Sorry, not Igor Zanich. Sorry. I know a couple Igors now, or know of a couple Igors, so I got them confused. This is from Igor Severik, who is Poly Marvels online. If you want to check out his Twitter, there he is, Poly Marvels on Twitter, or whatever the heck's stupid thing. And here's his YouTube channel. He's got a lot of cool, procedural modeling type stuff and different like hard surface modeling and all that kind of stuff. So certainly an interesting look into how you might do some hard surface modeling in Houdini and sort of what that looks like. So hey Pip, welcome. This is who made the model for us, and it's the hey Sig, welcome. He made this little robot and kind of contacted me and was like, hey, what do you think about doing a little something with this robot? It'd be cool to see how you rig it and animate it and do that kind of stuff. So that's what I did. So I had a little bit of on and off time working on this, and then over Christmas break I just kind of said I'm gonna buckle down and do this, and figured beginning of the new year might be a good time to really fully go into this. So this is going to be what we're talking about tonight, is how to rig this little guy. And what I should say too is that these blue nodes down here are what I built. There is a little bit that I put into these nodes up here, but this is mainly what Igor sent over to me. I should say too that Igor works for Grayscale. And so he has kind of kept me up to date on some of what they're doing with the material stuff. So that's a pretty neat little thing that he was kind of talking to me about too. And I was able to play around with that a little bit, and it's cool. It's a cool process. So maybe we might even use that to do some texturing on this little guy in a future stream and talk about rendering and all that kind of stuff. But anyways, so these top nodes are what he's created. And can you import a model from Blender into Houdini? Yeah, of course. You could certainly import a Blender, something that was made in Blender into Houdini. Obviously, we don't support blend files, like their actual project files, but there's several file formats that can be transferred between softwares, Alembic, FBX, OBJ, USDs. I'm missing some more. Maybe GLTF, is that the other one too? I think that would work as well. So there's a lot of different options that you could do. But yeah, certainly you can get models between the two softwares. Hey, Wallaby, welcome. Wallaby 8. Sorry to all the other Wallabies out there. I didn't want to. I'm saying hi to Wallaby 8 in this particular instance, not 1 through 7. So, anyways, so let's kind of, I want to walk through this kind of as an exercise of how I went about thinking about rigging this, right? Because I was presented this as not my creation, right? Which is pretty common, in a production world. You're not always going to be the one making stuff and then rigging it and animating it and blah, blah, blah. A lot of times, you're going to be getting that from other people and teams and from different softwares and things like that. So I kind of want to walk through a little bit of what kind of my thought process was for this, and how I knew that we needed to, sort of break down the thinking behind it, and not just here's what you do and here's the buttons you press. So, so let's dive in. We're going to get started. I want to also say here that I am certainly not an expert on rigging, characters, anything like that. There could be something I did that's incredibly stupid in here. So if you see something that you're like, oh, that is not normally the way you did it, like, you should do it. Like, you should do this. And there's a couple things in here that I would like to go back and fix, and I'm going to talk about that a little bit. And that might be maybe the topic of a later stream, in a week or two or something like that. But, I kind of want to have a little series with this guy because he's so cute. Like, he's so fun looking. And I want to make maybe a little render with him at some point too. But so anyways, there's a few things that I actually really struggled with, that I was surprised that I struggled with, and some things that were incredibly, fairly simple that I thought would be way more difficult. So, yeah, of course. Yeah, that's kind of what I want to do here. There's a million things out there that talk about what rigs are and how they do. I'm going to try to give you my thought process and maybe give you some. No, Kevin, I'm not going to be using Apex for this at all. This is just going to be KineFX. Now, I believe that you could take some of this work and then use that in an Apex rig, but I don't know the exact one-to-one for that. And I'm pretty sure we didn't just just delete the whole KineFX workflow in order to go over to Apex. That would, I don't think that was the case. I'm not really a specialist in this specific area. This is just kind of my experience with doing this and like how I went about doing this and stuff like that. And I didn't want to be having these kind of three things working against me, where I'm not super good at rigging. I'm not, this is not my specialty area. I'm definitely more of a simulation dynamics kind of person. In my previous jobs, that's pretty much only thing that we used Houdini for, was that. We didn't do scene assembly or anything like that. We were Cinema 4D and then used Houdini for this, for effects and things like that. So that's really my comfort zone, is effects and doing things like that. And so for the rigging type stuff, I'm a little newer to it. I've been able to learn quite a bit recently, but I didn't want to have that going against me, where I'm still sorting out some of these things. And there was a few things here that I didn't know how I was going to do. And then adding Apex on top of that, it's going to just be a video of me fumbling around. So what I wanted to do is get this created, get this sorted out. And yeah, we could certainly use this for something, maybe to talk more about Apex at a later date when I'm able to actually sit down and understand it. Now, the tech side of Apex, I'm understanding more and more every day. I've been able to see a few different presentations internally and externally on Apex, and that's really helped me. It really is a crazy shift in how to think of. Hey, it's Michael Goldfarb. Hello, Goldfarb. Welcome. What's for dinner, Michael? Hope you're having something good. Or maybe it's just simple like mine. I just threw something in the microwave and had a little like rice bowl. Anyways, Michael Goldfarb is the other training lead, or one of the other training leads. There's a couple of us at Side Effects, and he is actually he's been around the block for in the rigging world. So it's good to have him in the comment section here to maybe right the ship if I give you some terrible bit of information. he can sort of do that. And actually, Michael was on the stream sometime last year. I think maybe the year before. Gosh, maybe it was a while ago, Michael. We need to do that again. And he was talking about all sorts of cool ragdoll stuff, and we had a nice chat about that, and that was really fun. So go back and check that out if you're interested in more in character stuff, like a bit more advanced stuff than what we're going to be talking about here tonight. But mainly what we're going to talk about here is IK, basic rig setup and weighting and things like that. And then I actually ended up finding that there was a curve solver that made a lot of sense to use for this this neck spring, because I needed something that was going to be obviously flexible. So this is going to be hopefully a cool little demonstration on how I went about doing this, and maybe it'll give you some help with how you might go about doing some things like this in the future. This model is super fun. There's a lot of really cool like little details that Igor put in here, like a little antenna and the grill and this little wire and everything is really well done. Like, it's really fun. All the little bolts and stuff are here. Like, kudos to Igor on all this work. And he was even super kind enough to put my logo on the front of this little guy. He has a version where his model is on there. It actually might be in here too. I can't remember if he left it in here and just, no, it's off. But he was like, "Oh, do you have your logo? I'll put it on there." I was like, that's super cool. Nice. Thank you. But anyways, this guy is really nicely modeled. So we don't have some ugly nonsense for me to be working with. So it won't be all boxes and spheres and things like that. It'll actually be some real geometry. Hey, I almost want to say goat head, but it's go ahead. Yep. Goat head is the name of an old sports ball logo for a team that I'm a fan of. And so I was like, goat head? What? Oh no, go ahead. Now I see. Anyways. All right, let's dive into this. Let's start get going and stop with the chit chat. Let's get to some real stuff. So, like I said, this is the stuff that Igor sent to me. You can see that he has it broken out into a few different things here. The ground is just that. It's the ground. Particles and dust. He just kind of threw some in there for some, depth of field little dots on some renders he was making. I can't remember if he actually, let me look here. I don't remember if he had done anything in here out or if he did something in stage. He did something in here. Oh, cool. Well, I forgot that honestly, I don't even know if I've ever looked at this, but there is a render in here. So that's kind of fun. I'm not going to launch that right this second, but That's cool. And so, yeah, anyways, oh, I was looking for this node. That's what it is. Mesh. Cool. Anyways, I was looking for that earlier today or yesterday at work. Anyways, so he's got these in here mainly for rendering type stuff. And then these are where all of the modeling kind of operations have been done. So let's kind of just take a quick little browse around here at what he's got created here. So the head is isolated. We've got his eye protection. I like that. We've got a little mouth there. It's a little hard to see in the gray, in like the gray shaded, but there's a little mouth there. There's this little, he called it signal. I don't know what it is. It's like maybe like a little LED or something up there. You got the iris for the eye, or iris behind the eye, and then the eye itself. So the iris is behind the eye. Is it like, I'm not sure what, it's like another sphere back behind it. Got it. So there's a few different elements to this, to the head area here, but that is the general gist of this. And if we go inside of here, we can see how his process works here. And, you know, I'm not going to go through and break this all down because I truly don't know every single little detail of what he's done here. But he's made a bunch of different geometry operations and, you know, a whole bunch of different things. So, let me just do this. Let me hide other objects. That'll probably look nicer. So, yeah, you can see kind of what's going on here, how he's done this, how, you know, where he's done his edge flow and different things like that. He's doing subdivision modeling here. So some of it's subdivision modeling. I think some of it's like hard, you know, box modeling type stuff, and, you know, a mix of all sorts of different processes. So I'll talk to Igor. Actually, I did forget this because I would like to provide this file if I can, but I just want to make sure he's okay with that. So I usually do upload these files after the fact, but this time I'm not going to do it until I hear back from him. So I'm going to have to remember to ask him that because I don't want to give away his stuff. You know what I mean? If he's, you know, got something that, you know, he did or whatever. So one thing I did notice, which I don't know what the issue is here. So there was a weird thing that I was running into a lot with this was I was clicking on some of his nodes and they would actually jump the geometry around in the scene like that. And so I'm not sure what exactly is going on here. Like there's some sort of weird thing that's going on here, but it seems to be okay. I'm just going to try to not click too many random things. He gave this to me as like locked files and stuff like that. So had locked edits in it and things like that. So I actually meant to ask somebody about this and I just got lost in the weeds of actually doing the rigging and never asked anyone on the you know, development team about why that would be happening. So anyways, this is the little comm device here. We've got a few different elements. We've got the cable, we've got the case, we've got an antenna here. We've got signal lights. We've got this little cartridge on the top and the plug that goes down here at the bottom. So when I saw this initially, I was like, oh, this is an obvious, you know, place where we could use some secondary animation. And if you're not familiar with the secondary animation node, that basically takes the animation of your main character and kind of applies it down a joint chain and creates these kind of really fun little extra bits of animation without having to go through and animate those individual joints. So we're going to do that a little bit here, but I'll also highlight some of the struggles that I had with that, which I was sort of surprised with, but you know, anyways, it ended up working out in the end. But I was like, oh, I'm going to spend, like last night I was like, oh, I just got to add that in. And it ended up taking me like 4 hours to do it because I kept running into all these goofy issues. So, so anyways, we'll get to that in a bit. But, and then finally we've got these legs here. And this sort of brings up an interesting issue here because we have this kind of quad symmetry, right? And so obviously we have, this is all made kind of different ways. So we've got this, I'm guessing this is something in another language. This, I think, Igor's from Croatia. And so this must be maybe mean spring in Croatian or whatever language he might speak, which shame on me for not knowing what language Croatia speaks. But, yeah, so that, right. Actually, I didn't do, honestly, the weighting is super simple. Like there's very little weighting that needs to be done. The only thing that gets weighted is the spring, the little wire, and the antenna is the only things I weight painted. Those are the only three things, or actually had like weighting on it. The rest of it's just linked rigidly to because it's a robot. So everything links rigidly. So it was really simple. So I think hopefully that will be fairly simple to understand, and it was pretty straightforward. So anyways, this one's easy. Obviously it's that. We got the torso in the middle here. We got my little logo on the front, which is great, cool. But then we have each of these legs, right? And so the interesting thing here that's a little different than maybe how I would have done this, which is fine. There's nothing wrong with how this is done. But when we look here, we can see that each of these fourfold symmetry here, they're all together, right? So we have the middle legs. Yeah, exactly. Capture pack geometry. It's coming. It's coming. Exactly. Yep. Carlos is right. Obviously, Michael knows his deal. But yes, that's exactly correct. The capture pack geometry, and I know that thanks to Michael. So thank you, Michael, Mr. Goldfarb, in chat. So anyways, we've got all these different pieces here, and probably what I would have done if I was thinking about this from a rigging standpoint, which I don't think when he was creating this, because he had his own like Polymarvels logo on the front of this, and this was not, I don't think he was thinking about something with this being, rigged or whatever in the end, but he was like, oh, that might be cool, and I think he got in touch with me. So what I would think about here is making one leg maybe, and then mirroring that around, right? Because when you mirror that, you could then just increment the name of each of those leg pieces, because really in the end, that's going to be a big thing that we need, right? We need these separate names for each of these points so we can know how to bind our structure together, right? Or bind our geometry to our rig. So again, we just got some hip joints here. We've got wrist joints. We've got two different wrist joints. They go on either side here of this like, I guess it's wrist. It really feels more like it's knee, but anyways, wrist joint. Hip joints, leg spikes. Those are the actual big spikes. We've got the spiky shields here, and then some bolts and other bolts there. So what we need, though, is we need unique names for each of these, right? And so when we go into something, say, like hips here, let me open up my geometry spreadsheet and take a look at what's going on here. These are all named, hip joints, right? And so that isn't really going to do exactly what we need them to be. We need them to all have unique names. Now, luckily, there was this copy here that I was able to kind of use in pretty much all of these cases. There's a copy in there, so that makes this work, and it makes it fine where we can make these. It's a big chain of edits right there, but all of these at the very bottom have these copies, right? And so what I ended up doing was going through each of these and turning on the copy number attribute, because what that's going to do is give me a unique integer value for each copy that's made. So whereas at this point here, we have one leg or whatever. And really what we're doing here too, I should say, is we have one of these pieces and then he copies it around, right? That's what he's doing. I think for me, I would have just done that all in one go, but I'm not a modeler either. So there's probably a great reason why he didn't do it that way. So yeah, anyways. But so luckily we're doing this with this copy, and this has the copy number. We can grab that. We can get exactly what we need from it. These are also named, which is also very important, because then we can use that to help us along. So we're going to use these copy numbers when we're doing the rigging and all that kind of stuff to kind of get these pieces all together. But this is the hardest part of all of this, I would say, is like the legs really is kind of the toughest part to like make sure it's rigged properly, right? You want to make sure the joints are in the right spot and everything like that. So as I was looking at this, I was kind of like, okay, so we're going to have one joint here, right, for the hip. Then there's going to be a joint here at the leg. And then there's going to be one at the very tip down here to kind of drive our whole IK setup. Because really we just have two pieces here. So our IK, or our inverse kinematics, is going to be driven by this tip point here. We're going to have this middle kind of knee joint here, and then we're going to have this root hip joint right here. And so that's where we're going to get that IK setup from. And you could just do this with forward kinematics as well. That's totally plausible, possible, where each joint you just go through and edit and do all that kind of stuff. And you could do your IK and then do some extra posing in FK on top of that if you want to. And then when you get to, Apex and you've built, you've brought these rigs into Apex, you could have that be able to be switched back and forth. So that's really where the beauty of Apex comes in. And that's the benefit that you're going to get there, where you're going to be able to be switching back and forth between these different types of logics and things like that. But for right now, we're doing this in KineFX. So I'm basically just like, okay, these can be IK. That should be fine for what we're doing. It's fairly simple. There's not a ton of pieces to it. But I do need to get these locations, right? I need to get a hip joint location. I need a, like kind of this knee joint location, and I need the tip of this location right here. So that was kind of my process, was like, how am I going to go about and do all of those? So I kind of started, the first thing I went through was building this skeleton here. Not any rigging stuff, nothing, not calculating any weights or anything like that. I just thought about, okay, we need to build a skeleton. And of course, in KineFX, skeleton is just points and lines, right? That's the beauty of it. It's geometry. So any geometry operation that you can pretty much make a point or a line with can build you a KineFX rig, right? That's the beauty of the whole setup, right? So this is sort of my KineFX rig right here. And there probably are better ways to do this, right? Like maybe that antenna should have been linked to these antennas should be linked to somewhere else, and blah, blah, blah. We'll walk through each of these pieces and parts. See, there you go. Fully rig one leg, then use KineFX stops to duplicate it. Yeah, you could do that as well. That's not what I did, but that's a way smarter idea. Michael, I should have run this by you. What a dummy. But anyways, I'll show you what I did, and then we can go from there, and then we can talk about ways to improve and make things better. But yeah, that makes so much sense. That hadn't even occurred to me. So I love that. That's a great suggestion, and really is the smartest way of doing this. So we'll look at the slightly dumb way of doing it, or the slightly harder way of doing it, and then go from there. So what I started doing was just pulling in these pieces, right? Because I knew that way you could have more legs. Yes, that's true. You could just keep going. You could make it procedural, right, with the legs. And that's a great point as well, because in this case, it's way more, this is like more of a kind of rigid geometry. This isn't a procedural model, right? There is a bit more fixed edits going on here. This is a bit more hard surface kind of subdivision modeling in Houdini than true procedural modeling. But if you were doing procedural modeling, what Michael mentioned there it makes perfect sense, because you could then edit the number of legs that this creature has and just say, okay, I want to have it 6 legs instead of 4, and you change a slider. You take that one rigged leg, copy it more, and you've got more elements that you can work with. So yeah, that would totally make sense, and would be obviously super logical to do as well. So yeah, Carlos was asking, do you find useful straight skeleton 3D to make the skeleton? I'm not sure what that exactly means. I did use the skeleton node to kind of help make some edits to this stuff and kind of tweak things around, and just kind of for like a first pass on this skeleton being, an actual kind of seeing it as a rig, and then tweaking it and moving things around. I think I split a joint here for the neck and did some other things. And this was helpful for doing that, to be able to kind of make these joints the way, in some form or fashion. So if you're talking about this skeleton node, that is what I used. I'm not sure if that's the skeleton that you were talking about, but anyways, so what I'm doing here is I'm just going to be importing these different geometries in here. And I should say what I did in these cases was I just packed the geometry when I was merging them in. And so now these are just one packed geometry. And so each of these are their own points, right? So when you're packing a geometry, you're taking all that geometry and saving it kind of in an instanceable manner with one single point. And so this way was just a really fast way of me taking the geometry that I wanted to, which is the torso, and turning it into a point and naming it and seeing it and all that kind of stuff, and knowing, okay, I've got the torso in there, and then kind of going from there with other pieces here. Like in this case, I got the hip joints. I got rid of everything except for that sphere. Yes. So that's a great point that Michael's making there. He's just saying that oh, it's a labs node. Oh, okay. I'm not familiar with that, actually. It's a great... Huh, interesting. Straight skeleton 3D. I was not familiar with this. Interesting. Yeah, that's interesting. Michael has some insight on that. I do not know totally about that, so take a look at the chat there. But he's saying that the locations that it finds aren't right, so or the right rotations for the locations for rotations. But yeah, that's interesting. I didn't even know that was a node, so shame on me. Yeah, so what I did here was I was basically just thinking, how can I take these hip joints and get a good kind of center for them, right? And so I just kind of fused them down to a point and then just checked with these copy to points to make sure it was in a good location, basically. And then I just named those hip. And thanks, Goldfarb. And then just so I could visualize like where those were going to be and make sure that they were sort of lining up in the right point after I fused them, I just added that in and they looked like they were pretty close to the right spot. So I was like, yeah, I'm pretty happy with that. So basically I'm just getting points for these hips. And then just to kind of continue along the same thing, I just have some geometry there that I'm using. And then I did a similar thing here with the wrist joints. And what I did for those is I knew that they were going to be around this. Let me see if I can ghost. Yeah, I knew that the rotation was going to go around this specific kind of joint here. So I was like, well, there's a piece of geometry there. And really, I just need the center of that, right? So those little bolts, I selected those and brought them in. So here I'm getting the inside bolts, just running a connectivity around them to get a class attribute. And then using this extract centroid, which I do kind of on or off depending on what the specific mode I'm kind of using here to get these locations. But now you can see that I'm extracting this centroid and I'm getting, let me just change the size of that a little bit. Guides, marker size, let's change that to 6. Just make it a little easier to see because we'll be doing a lot of points probably today. So there are the centroids of those. So I used the connectivity to make sure that each of these connected pieces had their own attribute, then extracted a centroid from each of those pieces. And then I did, I got rid of the class for whatever reason. I'm not sure why. Sometimes you just feel like getting rid of an attribute, I guess, but I got rid of that. And so now I've got this joint location here. So kind of what I'm doing here is building up these different, points that are going to work for me. It's like, these are the hip points here, or those are the hip points. And I just instanced some geometry to see it visualized in the viewport. So I could kind of see where exactly that would rotate around. And so then I just kind of kept going down the line. I got the head here, grabbed the head. And since, I think for this first one, I wasn't even thinking that extract centroid was a thing. And so I could have not packed this geometry before merging. I mean, I was kind of doing this on the fly and just kind of thinking of different ways to do it. So these are kind of all different methods of getting sort of the same thing. But what we need at a base level is points, right? So here I just took the whole geometry, extracted the centroid, and now I've got that center point for the head, right? So there's many different methods, as in every bit of Houdini, to get to this kind of end result, right? There's all these different options. So that's the head. Obviously, we just need 1 point for that. We're going to rigidly assign a bunch of stuff to it, so that's pretty straightforward. And then I needed to get the spike tips. So how did I do this? All right, just trying to remember this here because it was a couple days ago I did this. So I think what I noticed was that these tips have a point at the very end. And I was like, oh, that's good. There's like one individual point at the very end. So I think what I did is I moved them to the Y plane like this so that they were just right at 0. I kept only the point that there's only just 1 point now that's sitting right on the tip there. And I just basically said, if p.y is not equal 0, remove the point. So basically if it's not right on that, that ground plane, basically, just remove it. If it's not right at y0, get rid of it. And so since I moved everything to the Y plane here, kept it only at 0, and now I can, what I did there, oh, right. I wanted to move it back to the tip. So in this step here, I actually saved out a transform. I stashed this transform, which was basically how far did I move it up here. So then I kept only that 1 point that's on the ground, and I transformed by the inversion of that transform, and that brought it back down to the tip where it was before because it was slightly below the ground plane. So I wanted to make sure it lined up. And then just removed some attributes that I didn't feel like I needed there. There were some like FBX attributes and things like that. And then I just named it. A lot of these I'm giving names based on just the name of this node here, which in this case is toe. So I'm taking toe underscore and just adding, each of these pieces as an index kind of, or an integer value at the end of it. So here we're getting toe 0, 1, 2, 3, so forth. So this is an enumerate SOP. It's the same that I used over here for the hip. And I think, for the wrist as well. Pretty much any of those that are going to have a bunch of pieces around, that kind of fourfold symmetry. That's how I enumerated that. So, that was how I did that one. And so some of these things, obviously you could maybe have better or worse, examples of these things. Or there could be better ways of doing all this stuff. And like Michael said, doing one and then copying it, that does make some sense. Should have probably thought of that, but there's always like a million different ways of doing everything. So, this is just kind of how I came about it on my own and just kind of through my own kind of fiddling around with things. So, let's see here. So this next piece here was, bringing in the neck. And what I wanted to do here was a couple of things. So I wanted to take this point, but I wanted it to be at the base of this spring. And so what I decided to do, which, I mean, again, there's probably a million ways of doing this, but this seemed like a pretty straightforward way of doing it, was I took the neck coming in, all the things here, I extracted the centroid of it. Then I used the match size in a little different method here. I took it in, justifying Y minimum, but instead of it being to the world, I did it to the actual neck geometry coming in. So in this case now, I'm moving this point based on where I want to in the bounding box of the spring. So this kind of gives me a nice starting point for my rig. And as I'm thinking about this and saying this out loud, I could have very easily, now that I'm thinking of it, done the same thing and got the top of this spring. But I did that manually for some reason. And, hindsight, always 2020. But you could certainly do that same method here and have a root and a that's a fun one. Hey Drew, welcome to Andrew, welcome to the stream. So just remember, whenever I'm making these points here too, these are going to be my joints, right? So what I'm going to do here is have a kind of a joint here and eventually a joint here and a joint up for the head and a few different things, obviously the legs and all that stuff, but every point is going to equal where a joint is, and then we're going to connect those hierarchically with lines, right? So that's where we get our kind of point and line model of KineFX, right? So here is the neck. We're going to merge that in, and then finally I got this, this was a little after the fact, I got this case up here, extracted the centroid of that, and I wasn't really sure how this was going to work, and actually it ends up not being super needed, because of some stuff that I kind of figured out later down the line. And we'll get there shortly. But I was a little surprised by some of the things that I ran into, and I'm sure Michael would have a million, would have some things to maybe enlighten me with. But I kind of, this was 2 a.m. last night, like I said, and so I was surprised at some struggles that I had because I had done this stuff before, but with some secondary motion stuff. But anyways, like I said, we'll get there. So I took all of these separate objects here, right? And we're going to, or all these separate, now just basically points, some packed geometry, which are represented as points, and some, just straight points. You can see here that all of these are named, which is a really important thing with KineFX. Every joint is going to be named and have a transform, right? Those are going to be the two key things to keep in mind here. So I've merged them all together, and now I am going to do an extract all points. And so now we just have points. All of our packed geometry is gone. Everything that we kind of had before is all gone. We just have our geometry. We shouldn't really have any. We have copy number left over there, and I could clean that up a little bit too, right? Like to clean up some of these attributes, but it's fine for now. It's not the end of the world. So here we've got these joint setup. And I guess this is probably where Michael's but his suggestion of doing one leg rigged and then copying it makes a lot more sense, because what I ended up doing with the skeleton here is that this allows you to draw in how to rig the cable. Yeah, we'll get to that in a second. And I actually ran into some I wasn't sure if we'd be able to do that straight through secondary motion, and I'm pretty sure the answer is no, at least from what I've figured out. So I think that would be actually the best way to do that would be to run a Vellum sim on that joint, and we'll look at that because I bring those in a second. But first, I think what we're going to do is just talk about the straight rig itself, and then we'll talk about some of those extra elements. Just this kind of base rig here first. I added in those other elements later, and I'll probably just turn this off for right now, and we'll kind of just let that be. These are the other elements, the antenna and cable, and that's how I got those their rigs kind of built. So we'll talk about that in a second. But anyways, with this skeleton SOP, there's this nice view state. So if you go into it, it might look like that. You hit enter, you enter into this view state, and you've got all these nice things here that you can kind of build. And basically all of these points, you can just select one and draw a curve between them. I'm not really going to go through and do this, but you can kind of understand how this would work. You click torso, then click hip. That would create a joint there. You always go from parent to child. Like you go out from your the root of your object and build your hierarchies from there. There is also, what is it? It's this rig tree. Yep. I was just getting to that. I'm like, where is that? There it is. We could do this. Why is this not? Oh, there we go. Okay. So this is also cool because you can set up, you can see how these different, this is your hierarchical view of that same setup. So we could take, like if I wanted, let's just say I wanted to move one of these things around, we can actually take these and move them around like this. This is going to change their hierarchy and do some kind of strange things there. So you want to be a little, you want to be careful with that. But this would come in as a flat view normally. And then you could reparent, like Michael said, reparent, rename the joints, all that kind of stuff. In my mind, I wanted to make sure they were all named properly coming in first, as procedurally as I could. And so that was kind of my first thing there. But yeah, you can, this rig tree view is really helpful. And you can obviously rename and do some things there. In fact, I did not realize that was a thing. So I think then what I could do here is rename that to neck. So let's just see here. Can I do this? How do we? I thought maybe this would be more straightforward. I don't see how you can rename this. Inspect, no. Double click. Does not. Oh, maybe I got to be here. Sorry. There we go. I was just on the wrong node. That was it. Yeah. So neck. It's like I am double clicking, or not neck. What is this? This was renaming this. Oh yeah. See, that's interesting. It actually wouldn't let me rename it that way. Okay. So I guess what I did was a little weird. So I'm just gonna not do that and just say point. What was this? 0.15, whatever it was originally. Just leave it so everything's working the same. But that is a cool trick. I did not know that was an option. Because what I was going to do is basically just take these two joints here. Why am I not seeing those in the viewport? Hello? All right. Give me a second. I'm just going to, might have to reset here. How long does it take to master the software? Well, nobody really masters it. So, no, it really depends on what it is you're trying to do. And there's tons of long-winded essays about that type of topic. That would be a great question, honestly, to ask over on the Discord server, which I haven't talked about yet. There is a Discord server for the for this stream. You can go to HoudiniHangout.com, get an invite to that, and there's lots of great things there. Like if you're a beginner, there's a spot for you to ask questions. If you have maybe questions about more advanced things, there's places for that too. Super open to any questions. There's no oh wow, why would you ask that dumb question? There's none of that kind of stuff. So it's a good space to be able to ask those questions, be curious about things. So yeah, I would, there's a lot of talk there about beginners and learning things. So I would check out that channel and you get some good insight from there. Okay, so what I did here, because I knew I wanted to get this neck to be bendy, I just resampled that. And so now, since those both were named neck, they're all named neck. And so there was a weird fusing thing going on there that I didn't quite understand. With joint parent is more procedural. I'm not sure, Carlos, which one you're talking about. Yeah, I do some parenting here, down a little later here, using the parent joints. So yes, definitely is more procedural. Agreed. You could certainly do that as well. Yeah, I forget. There was a weird thing I was running into here where there was like duplicate points, and now I'm not actually seeing it. So I'm not sure what that was all about. But oh yeah, there are a couple. There's like double points here and stuff like that. So maybe I was just doing something stupid. So I just fused them to make sure that was just getting rid of those duplicates. And then I sorted those neck joints, in the y-axis, just neck, so that they would be in a reasonable order. I then had to fix some leg orientation here. So what this is doing is just a orientation along curve. There was some weird, it was finding some really weird directions like for these joints when I was just putting them in without this. And so what I did was I just selected these specific joints, or these specific lines here, and so all of these ones here at the end, because I was getting some weird pointing at the tip and the knee. So I just wanted to make sure that those were oriented properly. And I just added a little orientation on those for when we were going to feed this into this rig doctor at the end, just to kind of clean up this whole rig. I'm sure there's, again, a better way of doing some of this stuff. But I knew that this rig doctor would be able to take these lines and make a nice, clean kind of transforms, names, all that kind of stuff. So that was I just put this in at the front of it and then threw everything into the rig doctor. And now you can see we've got these little icons here that are showing the direction of these transforms. And you could do either one of these views, but you can see that the z-axis points towards the child. So that's something you can do here. Reorient to child. We can switch it back. Switch it back to little hats. And so you can see that these are all kind of pointing in those directions now. And so things are looking good. We've got these joints are pointing in the y-axis. The y-axis is pointing like this. So we're getting that. That was what I was struggling with the leg orientation. It was kind of like slightly wonky. So I was like trying to move the leg just in FK mode, and it was doing some weird stuff. So I was like, I wanted to fix that and just make sure that was right. Again, there might be a different way of doing that. Always open to hear suggestions on that. But yeah, so here's the rig that I made, and kind of a good little rule of thumb with KineFX is to use a rig stash pose just to save a rest transform for your geometry. You can do this with animating geometry or static geometry. It basically just takes, or animated rig or a static rig, and it basically just takes the skeleton here and this pose source and just creates this rest transform attribute here. So it's basically just duplicating this transform at this point. But if this transform was animating, this rest transform would just stay static. So that for right now is sort of where we're going to start this journey of rigging that I kind of started on. Hey, Epoxia, welcome. Oh, you just missed the first hour. That's okay. It was maybe 40 minutes you missed, really, in the scheme of things. Maybe a half hour. So anyways, we got this skeleton, and this is kind of where I started this whole process, because I was like, okay, I've got actually I didn't even do the neck. The neck was kind of a little later on. I just wanted to get it sort of rigged and figured out, right? Just to make sure that I could make sense of what's going on here. Because again, I'm not this is not never been my profession. I wanted to make sure I was doing this sort of the right way. So, okay, so this is my skeleton, and then I kind of set up the rig and the actual like execution of the rig in this next node here. So skeleton, we'll come back to this and talk a little bit about these cables and antennas. And in fact, probably during this, I'm going to try to play around with changing that wire to a vellum sim, because I thought that might be a fun thing to kind of see live anyways. I think I may have done that before in the past, but we'll get there in a second. Cool. So let's look at the KineFX rig here. So with this, I am going to do a couple of things here. I was actually thinking about today, and I was like, oh, I did something really dumb here, and I should have thought about it. Yeah, so stupid. I should have had these in line and not done this stupid split thing, but whatever. It was late at night and I was not thinking straight. Anyways, we could maybe clean that up, but I'm not going to do that right now. So what the process with any rig is going to be here, and I think what I can actually do is get these out for right. Can I take these out now? No, not quite. This I could probably take out, but we'll get there in a second, I guess. So the main idea here with taking a rig and executing it right is you've got your rest geometry, or your geometry here for your object. You've got the capture pose, which in this case is just our skeleton, and then we have the deformation here, which in this case is I did a little like animation back and forth, nothing crazy here, just little wiggle back and forth. And so these are the kind of different geometries, and I can just put this in here and just say this is our rest geo. This is, what do we call this? This is our capture. And this is our anim. So I'll just put those there just so we can kind of keep track of what these wires are without having to look too closely. I'll just color those little different. Okay. So, so cool. This is kind of the idea, right, of KineFX, really of any rigging operations, right? You've got your rest geometry. You need to know what the kind of rest skeleton pose is, and then what the animated skeleton pose is, and then do that deformation based on that. And so that's what we're doing here with the joint deform. There's a bunch of other things going on up here with IK and this neck posing that I kind of did. This we'll get to in a second, but kind of the first thing to take a look at here, I think would be this. This is kind of me bringing in all the pieces for the model, right? So we've got the head. So I brought in all of those. I merged them all in. I think I cleaned up the FBX attributes, made sure it was named head, so that was matching. Because I knew that all of these pieces just were going to link together to head. Like they didn't really need to be animated separately. Like maybe you're going to animate this mouth separately. Great. You can name the mouth separately and give it a different, some different attributes and things like that to be able to bind them together with the weighting. But, I'm not animating the eye or the mouth or anything like that. It was just the whole head's going to move together. So simple enough. That's all going to be one name. Here's the comm device. Originally, I had this all named along with head. And so that was all getting deformed with the head. And in fact, I could probably do that pretty easily here. Just have to think about this. If I turned these off, possibly. And this should take in that. Just do that. Yeah, that should probably work for right now. I'll just have to turn this off here. So this will basically, when I turn this off, it gives these all their own unique names, right? So these all have their own different things like a plug and blah, 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 all that stuff. And so the wires and cables and things like that, I kind of parented later. But if I turn this on, they're all part of the head now. And so they're just going to get they're going to get weighted along with the head to the geometry. So then finally, we've got the legs here. Those come in. I split off the single pieces because I wanted to name them just with the name and copy number here. And that was the name I wanted to give them each. So each of these gets their own numbered attribute. So now you can see here, I'll just make this a little bigger. You can see that we have a whole bunch of different things. Middle legs 3, middle legs 1, leg spikes. So these all have now numbers after them. And this isn't a super complicated piece of Vex. It's very straightforward. We're doing sprint F, which basically just allows you to format a string. And so here we're taking a string, this percentage S. Let me make that a little bigger. We're taking this percentage S underscore percent I. So basically that's saying take a string, underscore, integer, and merge them together, basically, and put those into name. So basically I'm taking the name itself and just adding copy number to the end of it with a name, with a wrangle. And this is just running over all the primitives that are here, and I'm splitting out single pieces. So basically if the copy number is equal to -1, which if you see here, we should be able to see that a lot of these are at -1 because that's the default number of copies that attribute sets up. I think by default when it creates that attribute, it says if there's no copies of an object, it's copy number -1. Basically, that's the default value for that attribute. So if you have one that's empty, it'll just say, okay, we're gonna give that -1. So here at the split, I just basically say, pull out the ones that are greater than -1 and throw those to the left, and the ones that are -1 go to the right. So these are all the single pieces. And then I just merge them back together here once I've done this one little bit to it. I could also, I guess, have done that with a group syntax too. I could have just done that in the name pieces. Again, sometimes you just do things certain ways and you're just visually to kind of make sense of it. But that could certainly work just as well. So anyways, sometimes just talking through things helps me think more clearly than when I'm doing them without everybody over my shoulder. It's kind of funny. Anyways, and then again, I cleaned up some attributes here. So now we've got all this geometry coming in. It's all kind of named the way we want it to. We've got all of our kind of, duplicated, any geometry that's like a duplicate has its own unique name to it. All that stuff has kind of been sorted and figured out. So now we get to kind of some of the fun stuff here. We've got a capture pack geo. So what I'm doing here is I'm just getting our skeleton that we've made, right? It's got all the fun attributes that we've created on it here. It's got our, most importantly, transform and name, right? So those are on there. I probably could have cleaned up some of these attributes, but anyways, they're there. And so now we're going to feed that into our captured pack geometry with our model. And so what I'm doing here is I'm packing the input, right? So that's kind of an important distinction here, is that I'm packing that input coming in. So what that's doing then obviously is turning those each into, one single, unit that is going to be all, it's all going to have the same, it's all just going to be represented by one point, right? So all that geometry gets packed into one single point. And so I'm partitioning it based on the name. No, you do have to pack that. I was going to say, can you not do that? But no, you do have to do that in order for it to, so this is where we're getting our rigid weighting, right? So what I did here is I just, we could capture by attribute, right? But I didn't think that all of these would have exactly the same name. So, let's see here. Let me try this. Let me just try playing around with this on its own. So I'm just going to clear these out. You'll see that these all get visible again. So that's kind of interesting little UI thing. So when they're like this grayed out state, that means that they're actually bound. So it's kind of a cool little visual thing to keep in mind. But actually, if we do this, capture by attribute, that will find some of these elements, right? So now those are actually bound just based purely on their name, which is cool, right? So torso is linked to torso, some things like that. But it's not finding all of them. So what I could do is I could have gone through and named them all uniquely and all that kind of stuff, but instead I'm doing it this way. I did it this way here, which was a little more manual, but you could do it either way, right? So you could do it this way, and then what we could start to do is select these pieces together. So like here, I know that I want to take, let me see here, are we in the right thing here? So I want to take this hip joint, and I want to link that to it. Okay, so that just took hip joints 3 and hip 3, and it made a capture of those two. Could also do this with that. And if I shift click this, I think that's going to capture more things to it, right? Yep. So that's going to start to, yeah, exactly. It might be a good reason to name them all the same. Yeah. Yes. The, Michael and I did a whole, and actually would be a pretty interesting thing to talk about, I guess, in the future, but it's definitely a much more in-depth topic. But we were looking at some stuff with characters in USD and how you might represent that, and really having a really nice matching between your rig and your skeleton was like super, super important in all of that. And so being a little bit cleaner with that helps in a lot of these, can help a lot with all of these different name conflicts and things like that. It just can cause some real issues when you're dealing with USD. USD likes things to be a bit more specific, and you have to do some really tricky kind of naming stuff with it. And so we ran into all these issues, and my brain is not in that conversation right now, but yeah, that's a really good point, Michael. That having them, the better they are named, literally clicking this capture by attribute will just grab them all basically. So yeah, that is certainly a great point. You might be saying, well, okay, how are you going to capture this neck? And that is done in a separate step in a second here. So this obviously this won't be able to rigidly deform for a future hangout. Yes, exactly. For more hanging out. Oh, that's weird. Oh, no, it's not. Okay, that is the right joint. I was like, why is it not? Oh, okay, it's right there. Sorry, I was thinking that this was in the wrong spot, but it isn't. Yeah, so the better you have your stuff named, obviously the better off you're going to be. I did most of this just manually, just to make sure I was getting it all bound properly and stuff like that. In this case, we won't see the neck because I've kind of gone a few steps past with like the rig, like with those individual neck joints and all that kind of stuff. And really it's going to look goofy anyways, because it's going to be rigidly bound to it. But so this is really the capturing step here. So basically I just went through and did this visually in the viewport and just linked them together and stuff like that. And for example, here, since this whole object is named head, once I selected head and clicked here, that's done. It's linked together. If I turned this off, that will actually change what's getting linked here now, right? Because now it's seeing this and this as, oh, I need those to be separate, and those aren't going to be rigidly attached. So I have made some different rules for those. But for right now, they're rigidly attached to this whole head object here. So we've got our capture pack geo. So that's kind of doing its thing. And this is where all those rigid weights are going to come in, right? So here we have our bone capture. I think this would be the joint, right? Yep. Those are going to be the joints, I think. I just want to make sure I'm saying this right. Yeah, those are all my names. So yeah, this is the bone capture region, and this is the weight. And you can see the weights are just 1, right? So it's taking that, weighting it to 1. Good. I mean, technically you could unpack this, and you would, in fact, you'd probably do it here. You could transfer those attributes across, and they would all still be rigidly bound without it being packed geometry. But it's, whatever you need to do with it is fine. But I think that should work either way. But you have this weight on this whole object as just 1. It's not, there's no change along the object. Now, with something like the spring in the middle here, we do want this to be weighted separately along it. So we'll get to that in a second. Cool. Okay, so let's see how we want to kind of tackle this here. So when we get to, let's see this down here. Let's just see where we're at right now, because this is going to be a little funky, but you can see here oh, sorry. Yeah, so if this was off, that's kind of where we're at right now, right? We've got these things rigidly bound. There's obviously some stuff that's being done here, but we have these rigidly bound. We don't have the neck spring moving yet or anything like that, because that's done down here. And we haven't done anything with these joints. I'm going to talk about the legs next, because this is pretty interesting. And then we'll go back to this and you'll start to see how this joint capture proximity along with this neck posing is going to drive that. But let's talk about the IK first, because I think that's an important thing to talk about here. So the real thing that's doing a lot of this, the driving here, is this IK chains node, right? And so what this is needing is kind of two different things. It needs the skeleton, right? It needs the skeleton to work off of, but also needs some joints that will drive kind of this IK setup, particularly the goal and the twist. Those are two other like kind of driving elements that we need to use. So you can see here in the UI, we have a few different things here. Oh, actually, I was playing around with the neck as an IK chain. I forgot about that. I'll turn that off because I didn't end up using it. I wonder if that messed anything up, actually. Interesting. I forgot I had done that because I was playing around with that at first, see if that would work as IK, and it sort of does something, but it wasn't what I wanted. So anyways, so with an IK chain, what we're going to be looking for here is that if you move the end of this object, like my finger here, you want to be able to move this around and have the upstream stuff work and not have to go through and go bend to make it do the, the pose that you want it to, right? So if you're not familiar with IK, that's what it is. So what we need to do is kind of isolate some of these joints here. First of all, the ones that are going to be, that we're going to be using. Now it's pretty easy. They're all named, right? So we know here we have hip, wrist and toe. Those are going to be the joints that we're working with. So that's going to be straightforward. So what I'm going to do here is take a separate chain and create some driving joints that we can pose and then have those drive the IK. Now there's a really cool like setup that Matt Estella shows on his on the CG Wiki, which I should probably pull up and link to maybe after this, where he talks about the different ways that you can go about doing this and making it cleaner. Because really what you would want to do is take both of these poses, these rig poses, which is how you manipulate skeletons, right, in KineFX. And you'd really want there just to be one up here that would allow for all of these things to happen and not have to have separate poses for each of them. That's kind of a silly way to do it, but it takes a little bit more time, and this was just kind of the way I had it set up. So maybe that's another thing for another session. But anyways, so what we're going to do is we're going to isolate some of these joints. So here with this delete joints, I'm just going to say wrist star, and we're going to delete non-selected. So now what we have here is we have all of the, where's the name here? Name. There we go. So we have wrist. So we have all the wrist joints, right? Wrist star. But so we're also getting the selected joints and then the children of those selected joints, which is important. So we're getting the wrist and the toe because that's the child joint. So these are going to work. We're going to use these as our goal and our what is the technical name for that one? Twist. So those are going to be the two pieces that we use for that. So we're going to do that. We're going to run this through an extract all points or an add in the delete geometry but keep the points, which is such a weird nomenclature. That's like the weirdest Houdini thing, I think, is this add node that deletes. That's just very strange, but you got to have something weird, right? So so now we've got these points. Let me turn the point thing back on. So these are our points that we're going to use here. And all I do in this note here is I just wanted to get those knees to be in a little bit of a better location, right? Because if they're too close, that's a great point. You can also just create new joints. Good, perfect point. Yes. Yes, great. Michael's just saying that in the chat that you could make new joints. That's totally viable as well. I was just doing it this way because they were there and that was just kind of my thought process, but yes, you could certainly make your own joints as well. And so with this, I just basically displaced it a little bit in the Y direction just to kind of lift it up a little bit, or in the, in its up vector from the alignment, we had the up kind of this Y vector. So I just moved it along and displaced it a little bit in that direction. It's literally just moving the points away kind of, so they're out a little bit, because sometimes if they're, I noticed, and there's probably ways around this and stuff like that, but I noticed that if these points were too close to the actual joint, you get a lot of weird flipping pretty often. So kind of pulling it away felt like it kind of gave it a better direction. And you'll see in a second what those direction vectors do. But anyways, that's just those points. So now we still have these are still joints. They just aren't parented together. They're just kind of floating individual joints. And so I'm going to use the procedural option to parent joints. But you can see here, these are parented backwards, which you don't have to do. But I saw this on something that Matt posted on CG Wiki. And I thought, oh, that's a pretty cool idea. I like that. Because in this case, we're kind of just a rigid robot, right? There's not going to be a lot of super organic things that we need to do. So I think a lot of times just being able to animate this way will work really well. So let's look at sort of what this does. So, right, we take this IK leg posing, and now if we take something like the toe here, and I think if I do this, I'm just going to change the orientation for this. Oh, right. I had these in this weird mode for a little bit. I'm going to change this back to pre-multiply here. And if I hit Shift M, I should switch the mode. There we go. So now you can see that we can take these and move them around like this, right? Kind of in their plane. And we can also like do this with them, right? Oh, okay. There we go. There's the technical reason. I knew there was something weird happening, but Michael's saying that if the twist is too close, the IK solver doesn't know what to do, since there's technically more than one valid IK solution. That's great. That makes a ton of sense, right? Because you could do the kinematics could work one way, or it could work completely flipped the opposite way, and they both would be valid solves to the kind of problem that you've presented. So I had these. I don't know why I had these in this like post multiply mode. I think at some point I had like, oh, that's an interesting thing. But anyways, I had those in pre multiply. That's the default, is pre multiply. That's some matrix multiplication stuff that my brain's a little bit not thinking about exactly what it means right now, but I think it's whatever. I'm just changing it back to pre-multiply. Anyways, okay, so we've got these driver joints, right? And so these are going to inform the IK kind of solver here what we want it to do. So now when we come down here, this is going to be what comes out. This is going to be the IK solver here. And so what we do is we can look at that, and we can take, click on this. I'm going to see our joints here. And now as we move these around, you're going to see that these leg joints are going to kind of do their thing and give us some nice kinematics here, right? And if we take it up like that, right, since we have this all, set up here, I'm going to turn these off. These are some secondary motion stuff. This curve solver, I'll turn those off for right now. But since we have this set up here, I can go down to my joint deform, come up to my IK leg posing. Well, that was a weird way of saying that. And now I can move this leg around, and it's going to have that nice inverse kinematics look to it. It's going to feel like it just gives you, I think, a little bit more flexibility to be able to control where this is going, right? And ultimately what I want to do in a future stream, maybe possibly next, maybe we'll talk about rendering next, and then I'll get to some, we'll look at some other things. But I think one really interesting thing that you could do here through KineFX is actually do some procedural animation where you're just animating the position of these, these points and moving them around based on certain rules and stuff. I mean, this is a robot. You should be able to pretty easily make some really robotic motion with some procedural animation. So it was a thought I had. I haven't really fully fleshed that all out yet, but I wanted to talk about this part first. So I think hopefully you're starting to see how this works, and there's some interesting things that you could do here, right? And the nice thing about this is I'm just gonna, that was another thing I was thinking of too, is a crowd agent. Yeah, it's funny because the crowd agent thing is actually something that Michael and I had been asked by some instructors, and it was actually a robotic spider. So it's really funny that we keep running into these robotic like quadruped, 8 octoped things. Like, yeah, the crowd agent stuff would be really cool, and I think that could be part of where that procedural animation could be really fun to play with, like with a crowd of them or something. So yeah, certainly that's a great point. I forgot about the crowd agent stuff of it, but yeah, that's cool. So I keep hitting, let's see here for this, keep hitting Shift M. And so that switches the orientation of these handles. So now what I could do is I could just move this around on the ground plane, and you'll see how this is going to change it's going to just kind of follow this point, right? And so really, I think the rest position of this character would actually be a little bit more like this, where his toe is a little bit closer to his body, because I was looking at some quadruped robotics animations and stuff like that, like actual little robots. And there was one that was like a really cool, like step by step of like how you move the legs. And so they all had to be a bit closer than their furthest like extended reach in order to animate, what's the word? Propel themselves forward, locomotion, for proper locomotion. So anyways, this is kind of a neat little thing here. But the other thing that to keep in mind, if I go back to the mode where we're in kind of this sort of mode, is that if we tilt this back and forth, that's going to change the knee position, right? That's going to change kind of how this is solving. Now, I don't think if I move this out, it's going to change it a little bit, right? That could do something. But really just kind of tilting it to the side here is going to give us a lot of that nice kind of animation, right? And there's a little bit of weirdness here where, like, honestly, that was one of the first things that Igor and I were talking about, was like, how does this guy move? Like, how does he actually, what's his actual like movement look like? And I was like, oh, that's a good point. Like, I mean, honestly, when you're modeling something, it's kind of hard to know, like, oh, where are these things going to collide and do all this different stuff. But the really wild thing about doing this all in Houdini, right, is that if you were doing this and rigged it up like this and you're like, oh, I just need to go back and like tweak something. If this was procedural, you could just like change the scale of like a piece. Like here, if you wanted a little bit more range of motion so that these things don't like clip here, you could just be like, oh yeah, that needs to be a little smaller. Like, you could just change these elements to it. So I think that's one of the really neat things of all of this stuff kind of living in this more procedural mode like this. So, or in a world that's all mostly procedural. So again, if you guys have questions or thoughts, like Michael, I'm so glad that you're here chatting. That's so helpful. Thank you. I almost forgot to tell Michael about this. I was really mad at myself. I was like, Michael's done this since, I don't know. Michael, I hate to say how long you've been doing this, maybe over 20 some years, maybe in rigging. And I'm like doing this rig thing on my stream and I'm like, oh, I should probably tell Michael. Anyways, I mean, it's not a work thing, but it is something that is fun. Anyways, so the cool thing here with the KineFX stuff is that you can add posing after the fact too, right? So we could pose this this character like so. Then we could also do a rig pose here at the end and do some regular kinematic type stuff. Let's see here. Oops, no, M. And change, posing here, right? We could, like that if you wanted to after the fact, whatever. So it's all on the table, right? These are all, W is wireframe. That's right. So you can kind of layer these animations on top of each other. It's all able to be done like that. And I believe that's actually where this pre and post multiply actually come into play, depending on, I think, the order of those operations and things like that. But I think if you do override, it just completely overrides it to that. And if you're doing it from the rest position, it'll just be animating it from that original rest position and things like that. So there's a few different modes here, but cool. All right, so we're gonna just get rid of that. We're not going to do that. And I'm going to set this back to its clicking the wrong thing. Yeah, I just lost my mind. Wrong click. Shift or Control middle click reverts it back to its default. Shift middle click brings up that animation editor. 2002. Michael's been doing this a while. He's very wise. We'll say that. He's got a lot of wisdom. Michael, I was still in high school, so I bow to your superior rigging knowledge. Anyways, that's before I was born. Yeah. We don't all have to tell him how early before whatever X thing that was, but it is fine. Yes. Everybody gets older and it's a weird thing. And yeah, it's fun. It's fun. Getting older is interesting. Anyways, like your knees, like my knees just hurt now. I'm just getting close to 40 and it's like, yep, I can feel it. The body's like, I'm not happy with you. All this sitting. Anyways. Okay, so we got the IK chain set up. The next thing I went to do was the neck. And that was something that I was not sure how it was going to go. I was a little worried about it. And I was like, okay, well, let's see how this goes. I'm not sure what this is going to do or how it's going to go. But so the first thing I did was get these joints set up, right? Make sure that these are kind of isolated because I knew I was going to work on just these neck joints. And I started obviously with thinking, oh, maybe IK chains would be the way to go with this. And I started actually doing a little bit of research on this because I'm like, how do people solve this normally? And what I ended up finding seemed to be a good fit for this specific use case, and it's probably not for everything, is using a curve solver. Seemed to be a good use here. And so the idea here is fairly similar. What we're gonna do is have some driver points that are going to drive this curve solver, kind of like the IK solver. And so I think this is probably one of the most fun parts of this is this little curve solver, because I didn't really know that this existed in here. I mean, and it's different than like a wire solver, where you're like simulating gravity. This is actually solving either a linear Bezier curve or a NURBS curve from control points, which is kind of cool. Like it's just building it on the fly, which is really fun. I didn't know that was something that was in here in the KineFX stuff. And so this is a rig attribute VOP, which I know a very frighteningly little about. So huge grain of salt here. This was a huge learning experience for me, which was great. That's part of what the stream is for me, to play around and learn new things, but also learn from you guys, help you learn whatever the whole scenario is here. But this is what's going to do a lot of the driving here. So first of all, we know that we have to set up a very similar kind of control to what we did with the IK legs. However, we need a slightly different number of control points. What we need is, we know we have our neck here, right? And I set this to a very specific number of segments so that we'd have a middle. So it would be a nice clean middle. It doesn't really matter, but in my mind, it just felt cleaner to do it this way, where you have a designated middle point that we can select. So anyways, this was, I think I got this set up from something that, oh gosh, it was a Houdini 18.5 video, maybe right when KineFX came out, because that was KineFX release. And so I think this was in a video that was made that I'm sure Michael knows the video that I'm talking about, but I don't remember who it was particularly. I'm sure I work with him and I'm forgetting the name right now, whoever it was. But he did a couple of videos actually on different types of things. And this was one of them. And I was like, oh yeah, this is exactly what I want. Because really what you want here is you want to set this curve and be able to have some stretchiness to it, right? And that is the perfect thing here, is that not only can we build a curve from these points, but we can actually kind of do some stretching and animation from that, which is, nice. It feels like kind of like a spring, right? And so that was something that I felt made a lot of sense. And, that kind of was like, okay, this was a big moment to figure this out. And literally once I made this, I was literally like, again, I'm not a rigger, and so I don't build these kind of characters that often. And so when I was moving around the head and getting the neck joint to move, I was literally killing myself. I was laughing so hard because it looks so funny. But anyways, we'll get there in a second. So Michael's just pretty sure it was Henry. I don't think it was Henry Dean, but yeah, maybe. I'll have to see. Anyways, there's some videos if you're curious about the videos, I can maybe post them in the Discord. But so Michael's just saying rig VOP is just a regular VOP with some extra attribute stuff. And yeah, true. That's a good point. It's just weird because it doesn't have that like default VOP setup. Like these are all like, it's empty when you open it, which you're like, oh, why is it empty? What did I do? Did I break something? What happened? And there's only a couple nodes in there. So good news, there's not a lot of code or not a lot of stuff to figure out in here. You could probably do this with a rig attribute wrangle as well, I would assume. I didn't do that, but I'm sure you could do that as well. But we'll take it easy on the Vex and just do some VOP work. Anyways, so what I did is I isolated the joints that I wanted to use here and just did this to unparent them, just procedurally unparent them, basically just all joints, no parent, unparented. I wanted to, why did I do this? Delete joints. What is that even doing? It's doing nothing. I sat there. I don't know why that's there. Anyways. Sometimes you just do things. Oh, okay, cool. There we go. That Michael's saying there's also a Python KineFX API. So that's a good thing to know. So if you're into APIs, there you go. You get some, can do some KineFX in Python. So, okay, what I'm doing here, I don't know why that delete was in there. That was an accidental thing, I think. Oh, maybe it was, yeah, it was, it was supposed to, maybe I was thinking I was going to delete them. And then I was like, no, I got to change the name. And then I was like, oh, I got to add a delete. And I just had it in there twice. Anyways, so what I'm going to do is just rename these kind of procedurally. So I'm going to take the group 0 and name that root. I'm going to take the midpoint, which is just the number of points of the input, divided by 2 and set that to floor. Excuse me. I didn't think through the math on that. Maybe that's not the smartest one, but that was what that video was using. So I was like, cool, sold. So that's the midpoint. So that's going to get us our midpoint. And then endpoints of the input minus 1 is going to give us the endpoint. And so now I have those named root, mid, and end. So let's take a look at that. So just to see the difference here that we're setting up. So we've got root, mid, and end. These were all originally named neck, basically nothing through 6. And that was just built from the rig doctor. It cleaned up those names just to make sure that they weren't, so they were unique names, because every joint needs to have a unique name in KineFX. So that was why the skeleton was not allowing me to add a joint that didn't have a unique name. Couldn't be the same name. So luckily it's smart enough to do that, but I knew I was going to use the rig doctor to clean up some of the names. So I just did it that way. Anyway, so what we're doing here now is we're taking 0.0, that's root, 0.3 is mid, and 0.6 is end. And we're going to delete all the ones that are not root, middle, or end. So now that's what we got. And so these are going to be our neck posing joints, right? So we've got these joints we're going to use. And really this one is not going to move very much, really would never move, because that's kind of the base joint, right? So it only needs to be there just to create the curve. But those are the joints that are going to drive where this curve is being built. And so over here, this rig, this is going to be the setup here. So I don't think there's anything. No, I didn't do anything here. This is just all default. So, all right, let's dive in and take a look at what's going on here. And this actually, maybe I'll do this. So that's a little, I'll just maybe move these closer so we can see these a little bigger. Unfortunately, this X forms is dark purple, and so it's a little hard to see, but that's what it says. It says X forms. It's probably going to be a little muddy on the stream. This is points, X forms, local X forms. One really unfortunate thing I found out was that this local X forms is not, it's not implemented, it said, in the help documentation. So be kind of helpful in this case. You'll see in a second why that would actually be really nice to do, I think, but whatever. It is what it is. So you get what you can get. So what we're going to do here is we're going to get our point transforms. We're going to solve this curve, and then we're going to set point transforms. So what we're getting the point transforms is from a group, and we're just using name neck. So neck star. And so this is coming from the first input, and it's going to just be a group, right? It's going to be an ad hoc group based on a name attribute. So now we've got in this setup here, we've got our selection of points that we're going to transform. This is an array of points that we're going to get out. We don't have to use this actually anywhere. This is fine. And then we're going to set the same point transform. So we're using that to just kind of wire straight between here, and everything's going to be solved on these transforms here, right? So what we're doing is we're changing the transform of each of those points based on some driving points that we're going to do here. So this is basically all we're doing. This is in, this is out. Pretty straightforward. So here's our curve solver. So what this sets to, there's a few different ways that you can sort this. Interesting. Sorry. Yes, that's what I want. Sorry. I was like, it seemed like it was in the wrong mode, but it's not. Okay, so there's a few different modes that you can do with this here. You can set, you can use control IDs, you can do control transforms. There's a bunch of, curved geometry that could be coming in to the second input that it would be driven by. There's a few different ways that you can drive this. What I'm going to do is have control IDs coming in. So we've got control points. So let's just kind of look through this setup here. So we have control points. Controls input is going to be the second input, right? So we've got our controls coming in here to our second input. Those are our three neck posing joints. Those are coming into this curve solver setup. And so those are going to be our control points. So I just have star in there because I want to use all of them. The curve type is going to be a Bezier curve, so that makes sense. And the curve order in this case is 3, and I think that's just because we have 3 points, and that's how that would work. I don't always remember what the curve order means particularly. Yeah, it specifies a spline order. I just moved it until it made sense, and I was pretty sure 3 was going to make sense. I think its default is 4. But you can see that that's wrong. And I think that has to do with the number of points and kind of control vertices and things like that. So I think the curve order 3 is just making it so it works with that. Anyways, I don't know all the fancy Bezier math stuff for that. But anyways, there's a level of LOD for the curve. I believe that that's just setting the kind of how detailed we're making a curve that these points are going to fit to. So yeah, I think that's all that's really happening there. This also is a division, so I'm not sure why we have 2 of those there. But anyways, the curve divisions is again going to be kind of like a resample on that curve that we're going to fit these joints to. And then here we have the option to stretch, squash, and like tolerances for those. And also the look at axis and the up axis. So the look at axis is always, in this case, because we're using kind of KineFX joints, is going to make sense for it to be in that Z axis, right? Because you can see here that we've kind of have this Z axis going down all of these. And then the up axis is Y. That's kind of our up axis in this. There's a few different twist modes that you can do. I just left it in the default mode. What is the angle is the default? That's interesting. Huh. I left it in default. I'm actually curious what the difference would be there. Let's just see. Let's play. Well, we can just leave it in that. That's fine. And anyways, so yeah, so what we're doing here when we're working with this, let's just kind of look at what's going on here. Is we've got we'll just look at the curve solver here and not the finished thing. What we're getting is this curve that kind of fits to these joints, right? To these control joints. And as we move these around, we can see that we can control where this Bezier curve goes, right? And so this was kind of the big aha moment for me, because I was like, okay, yeah, this is exactly what I want. This feels like a spring that's, stuck to the root, and we're kind of moving it around based on this head joint. And then we can make some slight adjustments using this mid control, but it's not super necessary in order to get all these things out that we would maybe like otherwise. Let's see here. That's interesting. I moved that. I forgot I had a little animation on that. Not that it really matters, but sure, whatever. It's fine. It's all animated. Cool. So the one thing to note here is that this last joint is kind of sticking off from this end, position here, and this vector here, right? And so we can adjust that using this, using these rotations of this last joint. However, there is another mode, and right now I have this is what these last few things here are. We have the root and tip orientation. Oh, the twist mode is actually how it's going to go about looking at twists if we have it twist around like along the spline, right? So we're not really doing any of that. I mean, it control it, it would figure that out too. Yeah, I'm just doesn't really matter right now. So what these root orientation, tip orientation does is it determines how you want this to be set. Do you want the root and the tip to be set from the control joints or from the curve solving, itself? Because if we take, for example, the tip and change it to curve, now this is a really interesting situation here. When we move the tip of that joint here, we're actually going to get the head to kind of bounce around. And this was actually what I was laughing about, because like as you move this joint around, the head moves, right? And it kind of bounces around and keeps that angle at the end, right? So in this mode, it's kind of all controlled for you, right? Like the direction of the end of the head is based on how the spring is kind of pointing, right? And how it's being solved. So you can't easily have, like, if I move this, it doesn't do anything because it's only getting it from not the control joint, but from the actual curve solve. So that's what we're running into there. And that's why that works the way it does. So that's something to keep in mind, and actually was a big struggle for me when I got to the next part with secondary animation, and we'll talk about that in a second, but hopefully that makes sense and it's, not too in the weeds. I'm going to set it back to control for right now. Because then we can just pose this as needed. So this is a little bit more full control. Let's just say that this is the kind of fully controllable version, whereas, the other one kind of sets it for you, but you do need to animate it, right? So we added this change here, and now we have to change the rotations and things like that. And actually I hadn't animated this, so whatever. We can just move this. Where was it? It was in, why is it so hard to see that sometimes? Z is what it was. Interesting. You could add another rig pose and allow the user to blend between them. Are you saying before the curve solver setup or after the curve solver setup? How would you see that working? That's an interesting point. I'm just curious how that would maybe work. I'm just going to fix this and see what your thoughts are on that in a second. Set this back to 0 and nope. After. Okay, cool. I see what you're saying. So yeah, you could do it. Yeah, I got you. Right. So you could have separate like joints and allow them to, set those. I see what you're saying. Setting them sort of, then use a skeleton blend. Yes. So what Michael's talking about is basically, if you have a skeleton blend here, you can take an input and another skeleton here and set weights to them and blend between them and stuff like that. So yeah, you could certainly do that, right? And have it where it calculates it one way and then maybe one where you're posing it the other and then blend between them, depending on what, a user would want. I think you would need 2 of those curve solvers, right? If you wanted to have both of those, or maybe, yeah, I'm just thinking of exactly how that would work. But yeah, I think that makes sense to me. Yeah. Yeah, I didn't use any of this like skeleton blend stuff, that like kind of merging and blending pieces together in this setup, but I'm sure would make sense to do that sometimes. Okay, so let's now talk about some of this secondary motion stuff. Oh, I should also talk about the joint capture proximity. So this joint capture proximity, I'll just kind of move this to a spot where it's stretching, right? So this is how I'm basically capturing it based on this joint here. So I basically isolated just those joints coming in, fed that into the joint capture proximity, turn those off. And now it's looking at the closest joint to it based on the points. And we're basically, in this case, I have 6 influences, so it's got a pretty smooth blend between them. And there's this blend factor, which you can turn on and off. Oh, that's from existing capture weights. We don't have that, so it doesn't really matter. It's not going to do anything. There's no weights on it right now. And normalizing them, just making sure they all add up to 1 in the end. So just to look at what this looks like in different modes, we could look at some different number of influences here. So if we turn the influences down, kind of get some weird stretching because now it's only looking at each of these points on the geometry. It's only looking at 2 joints that it could possibly get influence from. So I kind of played around with that until I got something that looked pretty nice. I felt like, maybe 5 or 6, somewhere in that range is probably was probably the best. And the drop off is going to be how far I think it looks for those. And so you kind of want to make sure you're setting, actually, I think 6 is going to be better. You kind of want to go through and figure out what is working best for you for your, for your weighting and drop off. More or less the defaults for this felt pretty good, but I think for this one, I changed the drop off a bit. And you'll see why in a second, because it's smaller stuff. It's not as far away. These are fairly far away from this spring. So I wanted to make sure that they had pretty good, ability to find a nearby joint and get weighting from that. So again, what I should have really done here is stacked these together, not done this. I really don't know why I did this. This is very dumb. Let's see here. Let me just see if I can do this in a more intelligent manner. I'll do this live and probably will be a disaster, but we'll see what happens here. So, what I can do here is instead of... Now, I do just want to unpack these things. I don't want to have everything. So this split makes sense, but I'm going to get rid of this one out of the chain. We're going to do a little surgery on this here live, and hopefully I don't do anything too stupid. So this we want to grab... what's the name of that one? What's the name attribute of this guy? Oh, that's right. Feder. F-E-D-E-R. That's funny. And I'm going to turn this off because we're going to now bring all of those guys through. So we're going to have all 3 of those. So here I want to have this only look at name equals Feder. I think that should work. And then the capture group. Did that work? No? Oh, maybe that doesn't work. Maybe. Let's see. So I want to grab this. See, Andrew, thanks for being here. Oh, got a little no points captured. Oh, because I need to attribute promote that. That's right, because it needs to be probably a point attribute. Bye, see ya. All right, so we're gonna go from primitive to point. We're gonna do name. There we go. Now we're good. Okay, so it needs point. The attribute needed to be a point attribute. That's what the issue there was. So that seems fine. Looks like we're looking good. Let's see here. No, not happy. Not happy with us at all. Huh. Interesting. Okay. Well, I'm not going to try to troubleshoot that right now. I'm sure there's a reason for that, but enough makeshift surgery here. We'll just go back to where we were. Thank goodness for undos. Because it was working. There we go. Okay. Anyways. Weird. I don't know why that wasn't working. Okay. So ignoring my stupid little setup here, turn this off again. There's that. Okay, great. So this is just going to capture the proximity of this. Cool. This is going to be our joint capture proximity for these over here. What's it angry about? given parent. Now I've done it. Let me just see what's coming in here so I can make sense of this. Okay, we've got our geometry coming in. That's unpacked. Cool. And we don't have any lines there for some reason. That's fine. Because of this. Oh, right. Yes, we didn't. I turned those off earlier. That was why we're running into issues. Okay, so let's go back and talk about how I made the joint chains that are going to represent this capture here. So I'll go back up to the skeleton and talk about these. There we go. That's what we need. We need those and those. So at this point we have we're going to grab our cable curve. And so what that is I went up here and I was like, okay, let's look at this. Excuse me. Let's look at this comms device and let's look at the cable. That's going to be what we want to grab. And thank goodness, Igor made this in a really nice way for me. He took a curve here and did like a path deformation on it. And there's already a curve here. That's exactly what I need basically. So amazing. So I can just take this cable curve out and that's going to drive this setup here. So yeah, that's that weird transform thing again. Okay. So here we are. We've got our skeleton. Let's go in here and we've got our cable curve. So the one thing I did was I wanted to reverse it so that the numbering would go the other way. I don't remember why I wanted to do that. Oh, I think because I wanted to, what I was trying to do was see how I could parent these together. And this ends up not really working kind of the way I wanted it to. And so this is really more appropriate for a vellum sim. But anyway, so I'm going to do the same sort of trick here that I did for the neck, where I took those control points, except here I'm giving it a cable start, cable end, and just naming the rest of them cable. So if we look at these points here, we have cable start, cable end, and the rest are cable. And when those hit this rig doctor, they are going to, we have cable start, then we have it changes all the numbers of those. And it's just a easy, quick way to just throw them in there and it fixes it kind of for us. I mean, obviously you could be cleaner about this, but this is just kind of a fast way of doing this. So this is going to be the rig for that. And down here, I've got some parenting that I'm doing where I'm basically just parenting these joints to this head here. So it's basically, let's see here. How do I have this set up? I have cable start and antenna root, both parented to head. So that's where these joints are coming from this parent joint node. So it's a procedural joint, joint creation. And then up here we have our antenna. So the way I did this is a little differently because he didn't have a wire for this. He wasn't using any like splines or anything like that. And I was kind of playing around with a few different ideas. I was like, how am I going to do this? Because this one's was a little weird. And there's I'm sure many other ways you could do this. But he's using like a bend stop in here and some things like that, which it's really like, there's not really like a great way for me to kind of get that deformation from what I could think of. And like, yeah. So anyways, what I ended up doing was I was like, okay, I'm going to take the out from this and just send this into this skeleton node here and just go in here and see what I can do with it. So I grabbed the antenna. I saw that, this top little ball is a separate thing. So, okay, that's great. Let's get rid of that. So that class is going to be gone. Cool. Then I ran a fuse on all of these. And what I did was kind of played with the snap distance until I was just getting individual points along each of these, like kind of rows along this tube, right? So they all are fusing together to the center of these like rings here around this geometry. And then I sorted them all in Y so that when I connected them using the add SOP, they would all connect in the right order and we wouldn't have any weird looping. And then I just resampled it a little bit. This only has 4 joints. You could obviously resample it to whatever you would want it to be, you know, depending on how much bending and stuff like that you want to be able to kind of allow for and the type of bending. I just did 4 just because like whatever, it should be fine. It's not going to be super active. It's just going to be a little like springy thing and that'll be that. And then I just named them, I gave all of them antenna except for the base, which is going to be antenna root, just because I knew that that would get parented. Again, we parent that to the head. Get off of there. We parent that to the head and all is kind of right with the world. So, okay, so we've got those set up. The skeleton goes out and goes into our rig down here. What we're looking at here is a blast. So this is the whole rig like this. And if we look at that and just do the deformation, why is that not capturing? I think there's a reason for that. Oh, there's a reason for that. And the reason is that it's not coming through here. It's weird. Uh-oh. Got a weird transform thing going on here. Sorry. Ah, there it is. Just had the view flag in the wrong spot. It's like, why is it doing that? Did I miss something here? Yep, I added this name in here, named it cable, so that's right. It's really strange. Okay, there we go. I'm just going to see what these two things are doing and why they're not working. Maybe it is now. Okay, that looks right. Cool. Okay. All right, there we go. We're good. We're in business. Okay, so now here we've got this proximity capture that's going on. We've got this geometry here, and these are the joints that it's looking to make those weighting. And then here's the weighted. You can see the attributes weighted here. I turned the drop off down a little bit just because it didn't need to be quite so high. Set the max influences up a little bit higher there. Maybe you'd want these to be separate, you know, to get better weighting. It seemed to be working fine. So I was like, it's fine. It's good. So yeah, maybe you'd want to weight these separately from this, but it worked in this manner. So that was fine. Okay, cool. So then with that, since we have all of that stuff working together and those are parented to the, to the top of this, this head here, if we look at the joint structure here, that's actually showing the input as well. But we can see here that as that animates, since they're children of this head, they're going to move, right? So they're just kind of rigidly moving with it. And so that's all working well and good. That's looking great. So now what I wanted to do was start to add some secondary motion to some of this stuff, right? Because what we can do is we can use the animation that we're getting here and drive these joints with it. And so I was like, okay, cool. This should be really straightforward. I'm going to just grab this secondary motion. I'm going to select these top 3 points here, select this root as the driving point, and go for it. And I'll just show you what happens with that because this is not set up that way. So I'm going to turn this off actually again and just throw it in here. And we're going to do exactly that. So we're going to select, this is going to be the joint group. So it's going to be these joints, boom. And then the driver joint is going to be this one, enter. And okay, great. So I'm like thinking, oh, this is going to be super easy. This should all work just fine. We'll get maybe some, we'll do a spring or something like that. Cool. And I'm like all ready to see this work and do its thing. And I'm like, oh, this is going to be great. And I start animating it and I was playing with it. I'm like, what in the world is going on? This thing is not doing anything. I'm like turning the effect up to 10 and it's not doing, I'm like, what is this thing? It's not working. Like, what's going on? So the problem that I've kind of come to the conclusion here with some searching online and trying to understand, like I said, this was late last night when I thought this was going to be a simple thing to add in, is that the driver joint for this needs to have animated local transforms in order for this to work. And I went through a bunch of different things, like how can I get animated local transforms for all this stuff? Like, how does that work? Why is it? Because like you can do this on, like, for example, you could do this on like motion, like mocap data or whatever, and just have like, you know, if you're driving something from motion capture and then you animate, you know, have that animation, you want to add like the one example on the side effects documentation is like, if you want the tail to wag on a dog, you just add that in and it's all whatever. But the problem is you have to have this animated local transform. And when you have motion capture, every joint is, I think, because it's all moving, it's all animated, it's all doing its thing. In this case, these joints really aren't animated, really. They're kind of just getting moved because these joints are getting moved. So it took me a while to realize that limitation. And it said that in the documentation, but I was also like, how do I know what has animation? Because it's moving. Like, do you mean moving, or do you mean you have to actually be, what needs to be changing on that individual point for it to work? And so what I came to realize was that, let's just type transform here to get this sorted a little bit better. Oh, and put stars around it. Just going to only isolate this to that. Is that we have our transform here, which is the actual transform. We have our rest transform, but we also have this local transform. And it's the joints that are animated within that have the local transform animation seem to be the ones that are able to actually drive this secondary motion. So that was what I started realizing, like, oh, okay, so that makes more sense. And when I actually went to this curve solver here and set the tip orientation to curve, let's see here. If I go like that, I should see the, oh, I also want to do name in here. Sorry, just so I can see which point has the local. So now we've got these two next to each other. Okay, that does seem to be working. However, I kind of found that this was more necessary to have it set to control. So I'm curious to see if this works, actually. I did a whole bunch of stuff last night, so we'll see if this works or not. So what I did for this secondary motion is, instead of driving it from this joint up here, I drove it from this joint here, because technically these are kind of rigidly connected, right? Like, they should sort of work the same. So I was like, okay, let's see if this will work. So now let's see here. If I can, actually, I'm just going to say antenna star. Actually, sorry, that name. Okay, cool. And then I'm going to do the same thing with the neck. I'm just going to kind of make this a little smaller here, so we're only looking at certain things. Okay, cool. So let's see if this works. I'm actually curious if it works, because what I've seemed to find is that this only worked with the tip orientation in control and not in the curve mode. So let's see if this works or not. So we've got our secondary motion here. Yeah, it doesn't seem to be doing it here. Like, it wants to do something, but it doesn't quite do it. It's like, I think there could be something I do here. So if I change this to control, I think this will work now. Yep, there we go. Now we're actually getting something here. You can see we get this nice little wiggle from it, and it's kind of this really fun thing going on here. And let's take a look at the joint deform here. So I'm going to change the length of this so it's a little shorter, so we get this to loop around. And I think ultimately this is one of the things that is just so stinking cool about this KineFX stuff, right? And kind of the animation, this procedural animation, right, is that you can do stuff like this, which is really interesting. This isn't a simulation, it's just live, and I can change the properties of this spring constant however I want to. I can make it way more stiff. I could give it a little less mass and just kind of have it be like wiggly like that. I mean, obviously that looks stupid. I could maybe lower the dampening and it's never going to like stop wiggling. It's just going to kind of, or it might, wait, is that? Yeah, exactly. So there's lots of different ways that we can play around with this and get different properties and kind of situations here. Just lots to play with, obviously. So that was sort of one element of it, right? Is this secondary motion for this this antenna here. So the that was one thing that really tripped me up a lot, and I don't know all of the technical reasons for why that exactly is the case. Obviously, we're talking about matrix math here and a bunch of other things, so it's can be a little bit tricky maybe to process exactly why that's the case. I think actually don't want the antenna root in there if I'm remembering, if I'm thinking of this correctly. We actually don't want that in there, because I think that's going to make the bottom kind of wiggle in a weird way. Yeah, it's probably a little better. Anyways, let's see, where's that? That's right here. Just play around with this a little more and get a... Yeah, that's fun. Cool. So I'm not 100% sure of what all the matrix math reasoning behind that is, but basically what I read through some of the documentation was that what you're basically looking at there is the difference it's looking at some differences in the rest transform and the local transform, and using that to figure out how these secondary motions should be applied down this joint chain. And obviously here we're getting this benefit of the further this object is away, the more it's able to kind of act like a spring, right? It's actually able to act like this springy kind of thing going on here. So it's really, there's a lot of different maths going on based on the parenting and all that kind of stuff. And that's where the local transforms and all that stuff come from, because the world transform is basically telling you where you are in world space. The local transform, I believe, is telling you where you are in relationship to your parent, right? And so, that is, those attributes together are the things that are driving it. Now, why this curve solver working with this tip orientation in the curve, why that doesn't work, I actually don't know. I'm not sure why it doesn't work that way, but it just doesn't. And so, hey, that's what I found out. So I can't give you a better answer than it doesn't. Maybe eventually I can. But that was kind of a big stumbling point for me. So it's kind of an interesting thing to keep in mind, and something to keep, because it looks so straightforward when you see the demos of it, where it's like, you choose the root joint and that's animated, but these ones aren't. And then here we go. But it doesn't quite work that simply. And there is the documentation for that, but just something good to keep in mind. So that was kind of step one for the secondary motion. And step two, I was like, okay, could I do something with this little, what do you call it? This little cable here with secondary motion. And what I kind of came to the conclusion was, you can't really with secondary motion the way you would want it to, because you can't, at least in what I understand, you can't very easily have this joint here. So if we're looking at this right here, right? Like this. I just want to see those joints. There we go. That should work. So we can't have this joint here, the cable start, and the cable end both be parented to this head, because you have to kind of have a break at some point, right? There has to be this kind of natural break point here, right? It can't be like a loop. Like, that doesn't make sense in parenting, because there's going to be like this kind of, it probably is like a cyclical thing where it just would go on and for infinity and couldn't actually calculate it. So anyways, I was like, oh, right, I can't do that. So what I ended up with was something that doesn't work at all, which is goofy. And it's just like a broken cable, right? So it's like, okay, yeah, it sort of does something, but it's obviously not right at all. You could do something with like lag or whatever, or do jiggle or something like that, and it would, do something sort of whatever. But we can't have both of these things constrained. And so that was where I was kind of thinking, well, this seems like a really good spot to have a vellum simulation. Okay, that's an interesting thing as well. Use secondary motion on the midpoint of a curve solver. Okay. Yeah, that's interesting. I'm just trying to think of exactly how that would work. So you'd have the 3 control points. So it would be kind of the same setup as this here. And you would do the secondary motion in the position. I think it would be in that like position mode, because you can run this secondary motion in local transform mode, or you could do it in other attributes. So would you do it that way, where you would do it with other attribute and you would run it in P and just give it like the springiness of that? I think. Does that make sense? Let's try it. Let's see if we can do this. I don't know. On the position. Yep. Okay, cool. Okay, so what Michael is suggesting here, and I hadn't really tried this yet, so let's see if this will work. Ooh, but yeah, it's delayed. I gotcha. It's the whole thing has latency involved. I try to do it as low latency as possible, but I appreciate that. Actually, Discord is technically the fastest chat, because I could actually just see that. But yeah, no worries. Thank you for being here and chatting. It's been very helpful. So I'm actually wondering how that would work though, Michael, because I feel like you'd need more control points, because that's not just a straight it would sort of change the way that the Bezier would look, right? Like, because it's not like, in order to properly do this Bezier curve, you need a control point there and there and there, and like you need a few control points along here. So that would be a little different of a method. What I think would be the best thing to do personally would be to do just a vellum simulation on that. It seems like that would make a lot of sense. Just need 3 control points. A high point curve. Yeah. Huh. Okay. Well, let's give it a shot. We don't have anything to lose, right? That's what we're here for. All right. Let's see if we can do this. So the secondary motion we'll use in a second. So let's do a delete joints here, and we can just select maybe those joints that we want. So we'll just do that. We'll just say start. Maybe here will be the midpoint, and that'll be the end. Let's do that. Yeah, I think the vellum solve would be my preferred method personally, but whatever. It's totally fine. All right, so we've got these 3 points now. So, and those should actually be animated, so that's cool. Good. I mean, I guess it doesn't matter where this secondary motion goes. I guess we could do it like this too. I guess that would be fine. There's no difference there, right? Yeah. Okay. Anyway, so we're going to take those 3 points. Let's do the parent thing again, where we unparent them using this and just say that. Now we've got just points. This down. And this will be a little different. So we got to go in. Yeah, it's probably thinking it's doing it on the neck. Nope. We want to do it on, what's the name of those? Sorry. Let's see here. What was the name of those points? What are these? Sorry. Cable. Cable's the name of it. Okay. So I'm going to do that. I'm just going to come in here and do, instead of next star, I'll do cable star. Okay, cool. And so now this is going to give us a little different shape, obviously. But if we were to take this now, do secondary motion on it, based on the same kind of thing here, and we'll just grab that middle joint instead, this one here, and say other attribute. I think translation would be what we'd want, right? I think. Lag or overshoot. Next 6. Oh, right. We would need to keep that next 6 in here as well and then get rid of it before. Okay, that's right. Got it. So we need to keep next. Oops. Cancel that. Let's go back here and we'll shift click that. There we go. Okay, now we're getting something, and then we can delete next 6 here. And just delete this guy. And delete selected. Cool. Then we've got that. Okay. All right. We're getting somewhere here. Let's see what we got. So this is going to change it a little bit because it's changing that initial phase of it. Oh, that's cool. That actually works pretty well. Look at that. Michael. The legend. Nice. Here I almost didn't invite you. Totally on accident. All right, let's turn this up a little bit. Is that the right one? There we go. Maybe 0.5 is good. Could also maybe just do a spring. That might... Whoa, baby. That's kind of fun. I mean, I think obviously a vellum solve would be the superior thing to do here. I think you'd get a much better looking sim because you're taking that kind of start geometry and working on it. But this is certainly a really nice solution as well. So maybe instead of doing the vellum solve tonight, we'll just stay with this. I think that's kind of cool. And that makes a lot of sense, actually. Another thing that you might want to do here as well would be, you know, we're taking these joints, right, at this point, you might want to do like a rig pose just to kind of pull this joint out a little further. Like that could maybe be beneficial, I think, here. Let's see. This would work better in a crowd sim. That's a good point. So let's do this, and let's see here. I'm gonna hit enter, and maybe if I just take this and just all right. Oh, actually, if I did it, whoa, baby, did not like that. Okay, sorry everybody. Maybe if I put it here, so now they're not parented, and I can just, yep, that's probably better. Exactly, yep. Yeah, that's what I was just thinking of. So, so that's going to be a little bit better. And we can actually, now we can control this shape of this a little bit more and get a better look for the curve like so. So now it's pretty close to what it was before. And then we can see what this kind of turns into here now when we do this. Yeah, it's kind of fun. It's a little silly, but it works. So now we can see here that our two secondary animations are here, and are these like blue ones here. So it's this one and it's this one. So these are kind of two different ways to use secondary animation, right? We have one where we're using secondary animation on the actual points themselves, which is kind of an interesting thing to think about in general. Is like, if you had some, like, I mean, granted, you'd need to have these local transforms and things like that on some of your points, but you could get some interesting things like this with actual like point animation and stuff. It's just interesting to think about. Like, this isn't just like, secondary motion doesn't just have to be a KineFX thing. It can be done on like P and different things like that. So it's just interesting. Oh, and I should just say that this other channel here can actually take motion clips, which, just if you aren't familiar with motion clips, just to show you what those are, it's basically a way of taking out, like you can see here, these all have this time dependency. It's kind of a way to take animation and get rid of its, oh, I should look at it down here. It's kind of a way to get rid of the time dependency, right? Like, this is the motion clip, and it has all of the frames that are on my timeline here, up to 48. Oh, no, it's the whole thing, 240. You can set a frame range for it. You can do all this kind of thing. But basically what it does is it gives Houdini access to all of these frame steps basically at the same time, right? Here you have all these different times for each primitive. So each primitive has its own, they each have their own timestamp, and so that allows to do some calculations over time. So internally, this is happening within the secondary motion. But if you have your a motion clip set up for various other reasons, there's other things you can do, like blending of sequences and different things like that. But if you have that, you can wire that into that second input there, and get some good stuff from that. So that's why that second input and output are there, but you can do it without that. It has, I believe, that motion clip internally somewhere here. Yeah, motion clip, blah, blah, blah. There's probably other motion clips in here somewhere. I don't know. But anyways, yeah, right up here at the top. So whether or not you have that, it'll determine that and go from there. But so you can set your motion clip up earlier and have all the properties and things like that. But yeah, so there we go. I think we're going to start wrapping it up for the evening, because it's past the 2-hour mark for me, and that's when my brain just starts to shut off at a certain point. So have to give myself some needed rest from time to time. But yeah, if you guys have any like last closing thoughts or anything, it'd be great to hear, what you kind of got from this or anything like that. Or if you have any thoughts, like I said, I'm really hoping to kind of take this a couple more steps. It might not be next week. Depends on how much time I'm able to kind of screw around with this on the weekend, just completely honest. and we'll see kind of how that goes. Because I want to because this obviously is like a cool thing that Igor did and gave to me, and obviously to the rest of the community, to just have like a cool model to work with. And so I want to make sure that this is something not only just good for everybody, but is respectful of that, and we get some nice content out of it, and all that kind of stuff. I should say that too. There's no like paid sponsorship. There's nothing of that. Igor just came to me and we were like, hey, let's screw around with this. He's done some stuff. He's done some stuff for our education team internally for some training and things like that. He's just a really, really kind person. And so we were like, yeah, let's do it. Not making any money off of it, but hey, that's not the point. Let's teach some people some stuff. So that's a great and Keith says, I was saying in the chat that it could be for pre-visualization work, so it looks about 80% as good as develop some. Yeah, I mean, I think that's pretty true. And honestly, I think if you maybe even through some more, got your weighting a little bit better, maybe, just tweaked some little things here and there with maybe the number of points. You can get some different results based on the number of points in your curves. Certainly the antenna could even be a little bit better. But yeah, I mean, these aren't overly complex animations that we're trying to, with the antenna, we just want it to wiggle back and forth when it moves, right? With the cable, we want it to kind of feel like it has a little bit of weight. Now, the only thing we're not really seeing here is gravity, but we could use that actually. Now that I'm thinking of it, you could check gravity on here and wonder if that would give us a little bit more weighting. It doesn't really seem to be, I don't know what this is going to do for us, but yeah, it doesn't really seem to be doing a whole lot for that. It might not do much here. I don't know. Let's see if we get anything from it. Because actually the interesting thing here too is that because it's looking at the whole time of this, it doesn't actually matter. You can actually see this effect. You can turn it on and off here, right? Like it doesn't matter where you are in time because it's calculating this effect across, all of the frames and all that type of thing. You can actually see some of these things. Like you could put it in a pose and be like, oh yeah, how does it change? Well, really nothing's changing with this gravity here. So I'm guessing that in this other attribute mode, we don't really get a lot of, we don't get any real benefit from this, unless I'm missing something here, which actually, maybe this needs to be, Z and Y. I don't know. It's interesting. Yeah. Not sure. I didn't really look into this. Hadn't even thought of that. But anyways, yeah, it's a good, I think it could be great for some previs work or for anything like that, or for crowd work. I think that is a great point because a lot of people think, the crowds have to be all this like really high detailed stuff, but no, it really just needs to be convincing from a distance, right? That's the whole point of the crowd workflow, is that you're kind of sacrificing some features and some detail for filling in the background of your scene. So like, yeah, you're going to do maybe some cloth simulations and things like that. But in this case with a robot, like heck, like you said, this is 80% of the way to what you might even be able to get out of a really, really nice Vellum sim. And the final 20% is going to be a little bit of the rigidity and maybe some of the gravity stuff and that type of thing. And it's like, yeah, it would be really good for those types of things. So, cool. Well, great, everybody. I really appreciate, everybody being here and chatting. I definitely appreciate Michael. You've been super helpful with some of these little weird things that we kind of did on the fly. So that was super helpful. Thank you for being here. I will definitely remember to inform you a little more ahead of time the next time I'm going to do one of these, which might be next week, maybe not. We'll see. But I'll give you more heads up than 3 p.m. today. Yeah, I think that's where we're going to wrap it up for the evening. A huge thank you to, again, Michael, and to Igor at Polymarvels. If you haven't seen his website, or his YouTube, check it out. He's got a lot of cool modeling stuff on here. A lot of different random stuff that he's done, probably just things that he's interested in or whatever. Take a look. It's pretty cool. Also, he's on Twitter, and he works for Grayscale Gorilla, and huge thanks to them for all of those amazing new materials. If you haven't checked those out, you really should. There's some really cool stuff. I think Mark Fancher did a really cool tutorial on using some of their textures in like a cool animation with like pottery and stuff. It looked so cool. It was such a nice looking animation. I mean, the sim was really cool, and it was just nice overall. But anyways, huge thanks to those guys. Thank you guys both for being here, or for providing this. I know Igor is in Croatia, and so he's probably asleep right now, which good. You should be asleep. It's night. That's okay. You can always check out the recording later. So anyways, thank you all for all of you being here. Again, please check out the Discord server. Like I always look there for suggestions. There's a whole channel for suggestions on there. If you want the HIP files for streams. Now this one I'm not going to put up tonight because I want to make sure that Igor's cool with that. We'll see. I think he might be, but I don't want to be uploading his work as well without his permission. So we'll see how that goes, because again, he made it, so I want to be mindful of that. But so keep an eye out there. You can get HIP files on there. Check out, there's places. Welcome back, Joel. You made it. Hopefully you're safe and you didn't kill yourself while driving. Wow, was that your commute? Holy cow, man. Yeah, that's what I was just saying at the end here. If I'm able to get this to a good state with some of maybe the crowd stuff and maybe looking at the vellum, that should be pretty easy. I've done vellum with like KineFX stuff before. But if I can get maybe the crowd stuff, maybe some of the procedural animation, I can, I'll probably do it next week. Just keep an eye on, socials and the Discord and stuff like that. And I'll make an announcement based on, just what I'm feeling like. If I don't feel like this is at a good spot, I'm not just going to do it next week just to be like, oh, we're going to do another one. Like maybe it'll be 2 weeks and we'll talk about it again, and we'll just do something else a little bit different that I can just kind of do off the top of my head. Again, this is stuff that I'm having to kind of learn along with you guys in some way, which is good, because then I can help kind of say what I stumbled on, and Michael can tell me what I could have done differently and that type of thing. So it's good. It's a good learning experience for me, but also hopefully for you guys to see how I've, some of the things that I've kind of run into with pitfalls and ideas that I've had to come up against and kind of figure my way through. So anyways, yeah, so keep an eye on the social media stuff and Discord and all that kind of thing, and I'll make announcements based on those. And other than that, that should be stupid fade. I hate that. I accidentally did that. Other than that, that should pretty much be it for this evening. Again, thank you guys all for being here. Joel, thanks for driving safely. And yeah, I'll catch you guys next week. Thanks for being here, and hopefully this was just a fun experience and learn how to rig a little robot. And yeah, be more in this series over the next few weeks, I think. So we'll talk to you guys later. Thank you so much for joining, and I'll see you all next time. Bye, everybody.